Alright guys, your essential question for today is what are the basic trig identities and how do we apply them to simplify trig expressions? So we're going to go ahead and jump right into this and look at our first one. So notice I have tangent squared of x minus secant squared of x. And so what I'm going to do here, my hint, is to always try to rewrite things in terms of sine and cosine. So what I'm going to do is I'm going to rewrite tangent squared as sine squared over cosine squared, because that's a rule, you can do that. So I'm going to rewrite this as sine squared over cosine squared. Then I'm going to rewrite secant squared as 1 over cosine squared. I notice they have the same denominator, so I can combine these together and get sine squared of x minus 1 over cosine squared of x. Now, I'm going to go back and recall that one of my Pythagorean identities is that sine squared plus cosine squared is equal to 1. So if I could manipulate this and move this, move this cosine squared to the other side and move this 1 to this side, I'd have sine squared of x minus 1 is equal to negative cosine squared of x. And the reason why that's important is because if you notice you got sine squared of x minus 1, sine squared of x minus 1, that's equal to negative cosine squared. So this will be negative cosine squared of x over positive cosine squared of x. And so negative cosine squared of x divided by positive cosine squared of x is just a negative 1. And so the answer to that problem would be negative 1. For the next one, I've got 1 minus cosine squared. And so again, I'm going to go back and look at my Pythagorean identity, which is cosine squared of x plus sine squared of x equals to 1. Again, if I manipulate this, if I move this cosine squared of x over to the other side, I would get sine squared of x is equal to 1 minus cosine squared of x, and sure enough, 1 minus cosine squared of x is just equal to sine squared of x, and so that would be my answer, just sine squared of x. Another one, I noticed I would FOIL this out, and so what I would get if I FOIL this out, 1 times 1 is 1, 1 times cosine is cosine x, positive, negative cosine of x times 1 is negative cosine of x, and then negative cosine times positive cosine is negative cosine squared of x. I notice that in the middle, the positive cosine of x and the minus cosine of x cancel out. That leaves me 1 minus cosine squared of x, and again, recall your Pythagorean identity, cosine squared plus sine squared is equal to 1. I can manipulate this and move it over, so that would tell me that sine squared of x is equal to 1 minus cosine squared of x, which is what I have, and so that's automatically equal to sine squared of x, and that would be my answer for that one. Alright, for number 4, again, it looks like I'm going to have another FOIL problem. So secant x times secant x is secant squared of x. Secant x times 1 is secant of x. Negative 1 times secant is negative secant of x. And negative 1 times positive 1 is negative 1. Again, the two inner terms will cross out, which leaves me secant squared of x minus 1. I bet that's one of my Pythagorean identities. So if I go back and I look at my Pythagorean identities, I'm going to have to write this out, though. Cosine squared plus sine squared is equal to 1, which means that 1 plus tangent squared is equal to secant squared. And so you can go back and look. That's one of your Pythagorean identities, one of your 3. And if I manipulate this by moving this positive 1 over to the other side, I would get tangent squared of x equals secant squared of x minus 1. And sure enough, that's what I have, and that's equal to tangent squared of x, which would be my answer for number 4. For number 5, I have two fractions. I have 1 over sine squared of x minus 1 over tangent squared of x. This reminds me of one of my reciprocal identities. 1 over tangent squared is technically equal to cotangent squared, because cotangent squared is equal to 1 over tangent squared of x. So this is equal to cotangent squared. So I'd have 1 minus sine squared of x minus cotangent squared, and then I also remember that cotangent squared is technically cosine over sine. So cotangent squared would be cosine squared over sine squared. So I can rewrite that, and this is what it gives me. And then I notice they have the same denominator, so I can combine them together and get 1 minus cosine squared over sine squared. And this looks like a Pythagorean identity, so cosine squared plus sine squared is equal to 1. If I manipulate this and move it over, I would say that sine squared is equal to 1 minus cosine squared, and sure enough, that's what I have. So 1 minus cosine squared is equal to sine squared over sine squared, and sine squared over sine squared is just equal to 1. So that answer would just be 1. For the next one, I've got 1 minus sine squared divided by tangent squared. So what I'm going to do is, I notice that this tangent squared is equal to sine squared over cosine squared. So I'd have 1 minus sine squared over sine squared over cosine squared. And it looks like I can change flip this. So I'd have 1 minus, and then, so I don't get confused, I'm going to put this in parentheses, sine squared of x over 1 times, and then flip this, I'd get cosine squared of x over sine squared of x. So I change flipped it. I notice the sine squares, I've got one in the numerator, one in the denominator, so they'll cancel out, and that leaves me 1 minus cosine squared of x, and I think that's a Pythagorean identity. Cosine squared plus sine squared is equal to 1. If I manipulate this and move the cosine squared over, I'd have sine squared of x equals 1 minus cosine squared, and sure enough, that's what I have, and that's equal to sine squared of x. And so that will be my answer for number 6. I think I've got 2, 3, 4. I've got 4 more. All right, so for number 7, I have 2 more fractions again, and I notice right off the bat, this 1 minus cotangent squared, if I remember correctly, tangent squared is the same thing as 1 over cotangent squared because they're reciprocal. So I'm going to replace this, the second part, with tangent squared. Then I also remember that tangent squared is the same thing as sine squared over cosine squared. So I'm going to replace tangent squared with sine squared over cosine squared. I notice they have the same denominator, so I can combine them together and get 1 minus sine squared over cosine squared. Go back and pull up my Pythagorean identity. Cosine squared plus sine squared is equal to 1. If I manipulate this by moving this sine squared over, I'd get cosine squared is equal to 1 minus sine squared, and sure enough, that's what I have. So 1 minus sine squared is equal to cosine squared, and cosine squared over cosine squared is automatically equal to 1. All right, for the next one, looks like I'm going to distribute. So I'm going to distribute that cosine of x, and I'm going to get cosine of x secant of x minus cosine squared. Secant of x is the same thing as 1 over cosine, and the reason why that's important is the cosines are crossed out. That leaves me 1 minus cosine squared, and again, that's one of my Pythagorean identity. Cosine squared plus sine squared is equal to 1. If I manipulate this and move the cosine squared over, that gives me 1 minus cosine squared, which is what I have. So 1 minus cosine squared is the same thing as sine squared of x, and my answer would be sine squared of x. For number 9, looks like I'm going to distribute again. So if I distribute this time cosine squared, I would get cosine squared of x secant squared of x minus cosine squared of x. Secant squared of x is the same thing as 1 over cosine squared of x. The cosine squareds, one in the numerator, one in the denominator, will cross out. That leaves me 1 minus cosine squared of x. And I think, again, that's the same identity every single time. Cosine squared plus sine squared is equal to 1. If I manipulate this by moving the cosine squared over, I would get sine squared of x is equal to 1 minus cosine squared of x, which is what I have. So that's automatically equal to sine squared of x. And that would be the answer for number 9. Finally, the last one, number 10. I noticed that in the denominator, there's that 1 minus cosine squared, again, that shows up. So I remember my Pythagorean identity, cosine squared plus sine squared is equal to 1. If I manipulate this by moving this cosine squared over, I would get sine squared is equal to 1 minus cosine squared, which is what I have. So that's the same thing as sine squared. So I have sine of x, cosine of x over sine squared of x. And sine squared is the same thing as sine times sine, and the reason why that's important is because one in the numerator, one in the denominator, so those are crossed out. That'll leave me cosine of x over sine of x, and cosine of x over sine of x is equal to cosine over sine is cotangent of x. So the answer for that will be cotangent of x. All right, that's it for today's lesson.